Hello, everyone. My name is Sydney Brown, and I will be presenting my senior capstone project, which looks at the effects of El Niño Southern Oscillation on plastic ingestion in Wedge-Tailed shearwater chicks. Now, I looked at a total of 8 years where I had 3 La Nina years, 2 El Nino, and 3 neutral. I had a total of 20 to 25 Wedge-Tailed shearwater chicks per year with a total of 194. These individuals were analyzed by standard necropsy, and I collected their diet samples looking at both plastic and squid beaks, as well as both stomach chambers. These group of seabirds have 2 chambered stomachs with the proventriculus and the gizzard, and this is part of the reason why this group particularly has high plastic loads, is because the gizzard really retains that plastic. And said plastic I will confirm via attenuated total reflectance Fourier transform infrared spectroscopy. Now, for statistical analysis, I use various linear and multiple regressions with the following parameters: squid beak quantity, ENSO phase, which was determined via MEIV2 value, which is an arbitrary value provided by a model, the MEIV2 model provided by NOAA. And I also looked at year and organ. And I wanted to do this to determine the influence of each parameter as well as how the parameters interact and therefore potentially drive plastic ingestion quantities. Is it a case of once we know the effects of one parameter, does that explain most of the patterns that we see, or do we have to include multiple parameters? That's kind of what I wanted to look at. And each model was further analyzed with corrected ICAC information criterion, AICC, as well as model weights to help prevent overfitting of the model and to determine what is the quote unquote best model out of all the different models that I looked at. And then I also did parameter scaled weights to figure out which of these 4 parameters were the main driving forces behind the trends we see in terms of which occurred in the most consistently in the best performing models. Now, some expected outcomes: I expect highest plastic abundance during El Nino and lowest during La Nina. This is based off of studies showing higher plastic transport to the islands in terms of looking at plastic on the beaches during El Nino and lowest during La Nina, and neutral years again being kind of neutral. And for stomach chamber, I expect higher quantities of plastic in the gizzard, again, because it has really, really strong retaining capabilities. Now, when I'm looking at the count results, and keep in mind, I did weigh the items and we saw the same patterns. We saw that consistently regardless if you're looking at the proventriculus or the gizzard, or looking at the per bird results, 2010 had the highest plastic quantities and 2017 had the lowest. And if you see in this figure here, you can compare the different plastic quantities between the 2 different organs. And you see that consistently gizzard had higher plastic loads than proventriculus across all of the different years I looked at. And what the black line is the MEIV2 value to show how it varied over time. Now, it's really hard looking at this to see if MEI actually plays a role into how this varies over time. And that is when these models come into play. In regards to the proventriculus, MEI was actually the best driving predictor with a relative weight of 1.61. And for reference, a value greater than 1 means that the models with that parameter performed better than the average model in the set of models I looked at. And this is supported by the fact that the simplest model, plastic as a function of MEI, had the highest model weight, showing that that model was the best out of all the proventriculus models. And when it comes to gizzard, we saw that pattern for a year with year as being the best driver, and the simplest model involving year, like once again, having the highest weight with 92.5%. And when you're looking at per bird, once again, we saw year, granted not as strong of a predictor as when you're looking at the gizzard, but still it's the best performing model, which is just the simple plastic as a function of year. Now, when you're looking at the organ models, this is when things start to get a little interesting, and that you see that year and MEI were both very strong drivers, with year being a little bit stronger than MEI. And this is because what we expect is that we see this long trend over time with some interannual variation potentially due to MEI. And this is supported by the 2 best performing models involving year, organ, and MEI. And then when you look at these figures right here, they show the very strong trends that we saw in regards to the count specifically. Once again, when we looked at the masses, we saw the same patterns. When you're looking at the one on the left, that compares the plastic counts against the MEIV2 value. And as you see on the left side of the graph, we see high plastic counts with more negative values, which indicates that we find higher plastic quantities during La Nina, actually, than during El Nino. And when you're looking at the gizzard, again, year was the main driver. And you can see the strong trend over time where if you look at plastic, which is in the red, you see this strong decrease from 2009 to 2019 in the plastic quantities. And the overall trends we saw, once again, were 2010 had consistently had the highest plastic quantities, 2017 had the lowest. Plastic was higher and more common in the gizzard than in the stomach, which is what we expected. MEI was the primary driver for proventriculus plastic quantities, which is supportive of my hypothesis that ENSO does influence the amount of plastic ingested by these shearwater chicks. Year was a primary driver for gizzard and total plastic quantities. And when you're excluding the impacts of organ, year and MEI were the main drivers of plastic quantity. And this is very supportive of the driving ideas behind my project, where we see these general trends over time. But when you're looking at between several years, you see a lot of interannual variation. You have this giant trend line, and it can alternate up and down really easily. And I predicted that MEI was a source of that interannual variation, and this is very supportive of that. We saw plastic quantity decreased over time. And finally, La Nina, contrary to my original hypothesis, had higher quantities of plastic. And why this all is, I'd be more than happy to discuss with you at my Q&A session at the symposium. Thank you for your time.